Good day everyone, my name is Lemuel and we're going to talk about linear regression. So, the objective of this presentation is we will learn about linear regression, how it is for and how to use it. So, first of all, what is linear regression? Linear regression is analysis used to predict the value of a variable based on the value of another variable. So basically it's called just predicting using a mathematics. So the variable you want to predict is called dependent variable. The variable you are using to predict other variable is called the independent variable. So have you been wondering why is it important? So linear regression models are relatively simple and provide an easy to interpret mathematical formula that can generate prediction. Linear regression can be applied to various areas in business and academic study. So this is the equation of the linear regression equation. So let's try. Problem number 1. A local cafe has observed that as the number of coffees sold per day increases, the daily revenue also increases. So the coffee collected the following data over the past 5 days. So using the linear regression, predict the daily revenue when 55 cups are sold. So let this be an x and y. So the sum of this is equals to 255. So and the daily revenue sum of that is going to be 1,130. And xy multiplied by this and add is equals to 58,550. X squared is close to 13,625. So we're going to use, for the first formula, we're going to use this. So n is equals to 1, 2, 3, 4, 5. So 5 multiplied by xy. So xy is 58,550. 58,550 minus x. So x is equals to 255 times y is 1,130 over, and again is 5. So x squared is 13,625 minus x squared. So x is equals to 255 squared. So the outcome of this is going to be 1.48. So the second formula is going to use is the b is equals to this one. B is equals to y m x n. So b is equals to y is equals to 11,300, 1,130 minus m is 1.48 multiplied by x. So x is equals to 255 over n. So 5. So the outcome for this one is going to be, so going to be 150.52. So here's going to use the linear regression formula. So y is equals to m is equals to 1.48 multiplied by x. The dependent variable is 55. So 55 plus b is equals to 150.52. The outcome of that is 231.92. So this is the answer for problem number 1. So let's try to solve this problem number 2. A farmer wants to determine if the number of hours of the sunlight a affected the growth of tomato plants. He collected the following data for 5 plants, recording the number of hours sunlight per day and the corresponding plant height per week. Using linear regression, predict the plant height if the plant received 7 hours of sunlight per day. So let this be an x, the sunlight is x, then the plant height is y. So the sum of this is going to be x, so 30, the sum of plant height is going to be 210. So the x, so multiply this, then add all of those, it's going to be 13, so 1360. Then the x squared is going to be 225. So n is 5. So we're going to use this formula to solve. So the first step is so 5 m is equals to 5. So xy is equals to 1360 minus the x. So the x is 30. Then the y is 210. 110 over 5 again. Then the x squared is going to be 220. 20 minus the x squared. So x is, x is 30 and squared. So the outcome of this is going to be 2.5. Then, so the step 2 for this to solve is using this formula b y minus m x over n. So b is equals to 5 y is equals to 210. 210 minus m is going to be 2.5. X is 30 over n. So n is just 5. So the outcome of this is 27. So we're going to use the last formula, the linear regression. So y is equals to m x plus b. So y equals to m is 2.5. Multiplied by the independent variable. So the independent variable is 7. So 7 multiplied plus the b is 27. So the outcome of this one is 44.5. So the ask is height of the plant, so C10. So this is the answer for problem number 2. So let's try this. Problem number 2. A farmer tracks the amount of fertilizer in kilograms used in the yield of crops in tons. So harvested from different plots of land. He collected the following data. Using linear regression, predict the yield of crops if the farmer uses 22 kilograms of fertilizer. So this is the x and y. So the x is fertilizer, the y is yield. So going to sum this up is going to be 100 and y is equal to 20.1. So and just 5, 1, 2, 3, 4, 5. Then the x, y is multiplied, then add. So x squared is going to be 2,250. So the first step is to use this formula. So m, you need to get the m. So m is equals to n is 5. So xy is 2047.5. Then x minus x is 100, y is 20.1 over n. So n is just 5. Then x squared is 250 minus x 100 squared. So the outcome of m is 6.5882. So m is equals to 6.582. So next step is use this formula B to get to E. So B is Y is 220.1 minus M is 6.58.2 and next is 100 over 5. So the outcome of this is 137.62. So the main formula of linear regression is y equals to mx plus b. So y is equals to m is 6.582. So the independent variable is 22. So 22 plus b is equals to 127.62. The outcome of this is equals to 17.18. So this is the answer for problem number 3. So let's try this. So problem number 4. A farmer is tracking how much fertilizer in kilogram he uses and how it affects the yield of crops in tons. After collecting the data over several weeks, he finds that the following data. So using linear regression, predict the crop yield if the farmer uses 18 kilograms of fertilizer. So let the fertilizer is Y, the crop yield is Y, and X and Y. So N is just 5 because 1, 2, 3, 4, 5, then X is sum this up is equals to 100 and Y equals to 18.4. Then multiply and add this X and Y is equals to 2207.5. Then X squared is 2250. So the first step is use this formula. So M is equals to N, so 5 multiplied by xy, so xy is 2207.5 minus x is 100, y is 18.4. So over n, so 5, then x squared is 250 minus x is 100, then squared. So the answer for this one is 7.36. So this is the M. So next step is the B. So B y minus mx over n. So B is equals to y is 18.4 minus m is 7.36 multiplied by x, so 100 over n. N is 5. So the answer for this one is negative 143.52. So this is B. So the main formula for linear regression is y mx plus b. So y is equals to m is 7.36. My x is the independent variable, so 18 plus b. B is negative 143.52. So the answer is negative 11.04. So this is the answer for problem number 4. So let's try the problem number 5. A gym tracks the number of hours its members spend exercising each week and the calories burned during that time. Based on the data from 6 members, they want to know how the hours spent exercise affect the calories burned. So using linear regression, predict the calories burned from someone who exercised for 7 hours. So our exercise is up, you get the value of x. And this sum this up is the value of y. So just multiply x and y and sum this is going to be 19,300. Then x squared is 91. So the first formula we're going to use is m. So m is equals to n. So n is 6 multiplied by xy. Xy is 19,300. So 19,300 minus x is 21. So 21 and y is 5150 over 6. 6x squared is 91. 91 minus 21 squared. So the answer for this is 72.86. So this is the value of m. So next step is b. So b is equals to y. Y is equals to y. So 5150 minus m is 72.86. 72.86 multiplied by x. X is 21 over 6 because n is equal to 6. So the answer for this one is 63.33. So this is the b. So the main solution or formula for linear regression is y is equals to mx plus b. So y is equals to m. M is 72.86. So 72.86. So the x is the independent variable. So it is 7r. So 7 plus b is equals to 603.33. 603.33. So the answer for this one is 1113.35. So this is the answer for problem number 5. So that's all for linear regression. Thank you for watching.